Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the strain gauge load cell. Consists essentially of a cell that contains a piece of known elasticity, such as steel, with a modulus of elasticity of 2.1, capable of supporting the load without exceeding its elastic limit. A strain gauge is cemented to this piece, which can be made up of several turns of thread of 0.25 mm and glued to a paper or synthetic resin support, or it can be made up of thin bands glued to the structure under load. This gluing operation seems simple, but it is absolutely essential craftsmanship to obtain accurate and stable readings of stresses present in the structure. For example, weight. The tension or compression to which the weight subjects the load cell makes the length of the metallic wire vary and therefore modifies its electrical resistance. This resistance is calculated in this way. As the volume of the thread is constant, before and after it is put under tension, it is calculated like this, and the resistance change as the second formula. Signal conditioners are used, and they are Wheatstone bridges that pick up small changes in resistance and compensate for the effects of temperature. Here we can see an elementary circuit that has the disadvantage of the variable resistance of the connection wires from the gauge to the bridge. A complete circuit with 4 gauges, one on each arm of the bridge, for higher sensitivity. Here, a load of 453 kilograms or 1,000 pounds unbalances the bridge at 15 millivolts per volt of excitation. The addition of a microprocessor elevates the accuracy of the custom through the use of error correction algorithms and facilitates adjustment and calibration. The semiconductor strain gauge changes resistance with stress due to the changes in the crystal structure that vary the mobility of electrons. The gauge factor is higher than in metal gauges, being in the order of -50 to -200. The signal conditioner is also a Wheatstone bridge with the possibility of adding a microprocessor circuit. The load cell is the sealed and encapsulated assembly of the bridge and the gauges, provided with mechanical fixing points to join it to the structure, being suitable for most industrial weighting applications. In weighting instruments, the metrological standards of the OIML, International Organization of Legal Metrology, are applied, which classify the devices into 4 categories, which you can see on the screen. The microprocessor provides temperature compensation by taking average measurements and ignoring cell signal changes due to temperature variations, facilitates repetitive loading by controlling the difference in weight of the container in relation to the desired weight, provides communication with the process control system, uses barcode to automate weighting. With built-in intelligence, it can be part of distributed control. With proper mounting, it is immune to the influence of wind and electromagnetic interference. And with built-in intrinsic safety, it can work in explosive atmospheres. The cells are protected against moisture and dust, have an accuracy of 0.03% to 0.25%, support remote indication, and can measure weights from 20 kilos to more than 150 tons. Nevertheless, they require temperature compensation of the resistance wire and the remorphable steel part, and are relatively expensive. Hydraulic load cells consist of a piston on which the load rests, which exerts pressure on a hydraulic fluid. Depending on the load and according to the known piston area, a pressure is created in the oil, and it can be read on a Bourdon gauge, and therefore indirectly reflects the load. Adding the hydraulic pressures of various load cells and applying them to an electronic or digital transmitter yields a signal that can be read off an indicator and used in electronic weighting systems. Hydraulic load cells are manufactured for load capacities from 40 kilos to 90 tons. They have a quick response, less than 2 seconds. Their accuracy is ±0.25%. They admit overloads up to 40%. They can be manufactured explosion-proof, and they are resistant to vibrations. Pneumatic load cells consists of a pneumatic force balance load transmitter, in which the weight placed on the load platform is compared with the effort exerted by a diaphragm fed at an adjustable set pressure. The system adopts a balanced position thanks to the nozzle shutter assembly and the feedback chamber of the transmitter. The air pressure reached in this chamber indicates the weight. The load capacity of pneumatic cells ranges from 10 kilograms to tons. They have an accuracy of plus minus 0.2% and are easily adapted to pneumatic control. They have the advantage of being insensitive to temperature changes and being explosion proof, with the disadvantage of requiring compressed air and being relatively slow to respond. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I will upload videos every Wednesday in Spanish and every Friday in English. Adiós!